Hello, today we are going to discuss exercise 10.4 first question. The first question is two circles of radii 5 centimeter and 3 centimeter intersect at 2 points and the distance between their center is 4 centimeter. Find the length of the chord. It is a question that came for 2012. Okay, board exam for 2012 board exam. So we need to do the answer of this question. I think you understood the question. So there are two circle and the radius is given as 5 centimeter and 3 centimeter and it have a common, it is meeting at 2 points and it have a common chord. We need to find out the length of this chord. So we draw two figures. The figure we need to draw for the answer. So we draw two circles having a center O and O dash having radius 5 centimeter and 3 centimeter. That is given in the question. So we draw a common chord for these two circles as PQ. So we need to find out the length of PQ. For that, let us assume the triangle POQ. This triangle POQ. Let's assume this triangle. When you check this triangle, the sides have one relation. You get one relation with the sides of this triangle. That is 4 square plus 3 square will be equal to 5 square. That is 4 square plus 3 square is equal to 5 square. That is OP square plus O dash square is equal to OP square, that is O dash P square plus O dash is equal to OP square. That is, from this we can consider, we can assume that, we can conclude that the angle O dash P is equal to 90 degree because it is a right triangle. By the converse of Pythagoras theorem, we can say O dash P is 90 degree. That is, we got O dash plus O dash P square is equal to OP square. So we can say that angle O dash P is equal to 90 degree. Now, O dash lies in the common chord PQ. O dash lies in the common chord PQ because O dash P is one of the part of PQ. So we can say the point Q O dash lies on the common chord PQ. Now, O dash is perpendicular to PQ, right? O dash is perpendicular to PQ. O dash bisect the PQ, right? O dash is perpendicular to PQ, then O dash bisect the PQ because the perpendicular drawn from the center of a circle to a chord of it bisects the chord. Study from the previous theorems. The perpendicular drawn from the center of a circle to a chord of it bisects the chord. That means O dash is the center of the point PQ. O dash, sorry, not O dash. O dash is the center of the common chord PQ. That means it is easy to find out the length of PQ now because O dash P is, you know the length of O dash P, it is given is 3 centimeter and O dash P is given as 3 centimeter, that is, it is one of the radius of the one circle and it is easy to find out now O dash Q because PQ, O dash, we get O dash is the midpoint of common chord PQ. Now if it is 3 centimeter, here also will be 3 centimeters, so the total length of the common chord PQ is 6 centimeter. I think it is clear for you. Second question in exercise 10.4 is very important because it is repeated for 3 years 2012, 2016 and 2017. So mark it as important. Okay. Now we can move to second question. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to corresponding segments of the other chord. It's two equal chords, that is, for a circle you can draw a many equal chords. Here we draw two equal chords and we got two segments, and the corresponding segment of one chord is equal to corresponding segment of the other chord. We need to prove that. For that, we draw a circle with the center O, and it has two equal chords A, B and C, D intersecting at the point E. We need to prove that AE is equal to DE. AE is equal to DE and CE is equal to BE. For that, we draw, this O is the center, so we draw OM which is perpendicular to AB, we draw a line from the center to the chord AB. And also we draw a perpendicular line from center to the chord CD. That is ON, which is perpendicular to CD, and OM, which is perpendicular to CD. Now we join the intersecting point to the center. We join the intersecting point of two chords to the center. That is, we join OE. Now we got two triangle OME and triangle ONE, or this triangle and this triangle. Now OM equal to ON. Why? Because equal chords of circle are equidistant from the center. We studied that equal chords, we said that in the question. Also, it is said that AB and CD are equal in length. So, if we draw two equal chords, then the distance from their center will also be equal. So, OM is also equal to OM. Then OE and OE are equal because it is common. We are considering these two triangles. We need to prove that these two triangles are congruent first. So we took two sides. Both two sides are equal and OE is common there. OE is common there. Then by RHS rule, because these are 90 degree. It is a chord and the center line from the center to a chord is perpendicular. We studied that. So by RHS rule, by RHS congruency, right hand side congruency, we can say triangle OME congruent to triangle ONE. So by CPCT, we can say ME equal to NE. So AM plus ME is equal to DN plus NE. Why? We know AM plus ME is equal to AN plus NE. Since AB equal to CD, you know, AB equal to CD, that is two chords, which gives, that is AM plus ME is equal to DN plus NE, because AB equal to CD, which gives us half of AB equal to half of CD. Means AB and CD are two chords. Now when we take the half, the other also will be half. So from this we can write AM equal to DN. So AE equal to DE. From this we can write AB minus AE is equal to BE. AE minus AB minus AE is EB, and here CD minus DE is equal to CE. So from this we can write BE equal to CE. Okay, BE equal to CE. Third question is, if two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angle with the chords. It is also one came question, previous question for 2012. So the question, I think you understood the question. The question is, if two equal chords of a circle intersect within the circle, we need to prove that the line joining from the center to the point of intersection to the center makes equal angle with these two angles are equal. So that we draw two equal chords AB and CD of a circle with center O and intersecting these two chords within the point E. Okay, we need to prove angle OEA is equal to angle OED. These two angles, we need to prove these and these two angles are equal. We need to prove that. So for that, we join OA and OD. Now you get two triangles AOE and DOE. In that, just consider OA and OD. These two sides are equal because these are the radius of the circle, and OE is common there. And also AE equal to DE, because we proved that in the previous question. We proved in the second question. Also, so we can say OA equal to OD, OE is common, and AE equal to DE. By SSS congruency, we can write triangle AOE is congruent to triangle DOE. And also by CPCT, we can write now OEA is equal to OED. This is the third answer of third question. It is a simple question. I think it is clear for you. So the next question is, three girls, Reshma, Salma and Mandeep are playing a game by standing on a circle of radius 5 meters drawn in a park. Reshma throws a ball to Salma, Salma to Mandeep and Mandeep to Reshma. If the distance between Reshma and between Salma and Mandeep is 6 meters each, what is the distance between Reshma and Mandeep? So the three girls, Reshma, Salma and Mandeep, are playing a game on the park by drawing a circle of radius 5 meter, and they're playing as like Reshma throw ball to who? Reshma throw a ball to Salma and Salma to Mandeep and back Mandeep to Reshma. And the distance between Reshma and Salma is given as 6 meter, and also the distance between Mandeep and Salma is given as 6 meter. Now you need to find out the distance between Reshma and Mandeep. For that, we draw a circle of radius 5 meter, and we keep three girls on the circle and join these two. This is Reshma and this is Salma and this is Mandeep, and join these three points, that is RS and SM. RS and SM are two chords of the circle, and OR is one of the radius, same as OS is also a radius because these two are 5 meter. Now you need to find out the distance RM, that is we need to find out the length of RM. So first draw a line which is perpendicular to the chord RS as OL, and then joint OS also. Then when you join O and S, K will be the intersecting point of OS and RM. Okay, now this is the figure. I think you understood this. Okay, draw OL. First step is draw OL perpendicular to RS. Let this distance KR be x meter, KR equal to x meter. Now consider the triangle ORS. Consider triangle ORS. We just find out the area of ORS. What is ORS? The triangle ORS is made by the two triangles ORK. ORK and KRS. The triangle ORS is made by the triangle ORK and KRS. Okay. What is the area of ORK? The area of a triangle is half BH. So the area of ORK is equal to half into OK plus RK. OK is the height and RK is the base. So by 2. OK into RK by 2. This is the area of ORK. And what about triangle KRS or SRK? Anything. Half into KS into KR. KS into KR. This is the by 2. This is the area of these two triangles. So by adding these two, the area of these two triangles, we get the area of triangle ORS. That is OK into RK by 2 plus from the triangle this KS into KR by 2. KR. Then here OK KR by 2 plus KS KR by 2, and here KR and KR is common, we took it as outside, and OK plus KS is balanced by 2. OK plus KS means OS. OK plus KS means OS. So KR into OS by 2. What is KR? We took KR as x meter. So x into OS is 5. That is the radius. OS is 5. This is radius. It is given as 5 meter. So 5x by 2. Take it as equation number 1. Now, when you consider again the triangle ORS, we can say the area of triangle ORS itself RS into OL. RS into OL. In the previous section, we consider it as two triangles, and now we consider it as one triangle and took the height as OL and base as RS. So RS into OL by 2, which is equal to OL. RS is given as 6 meter because it's the distance between Reshma and Salma. So it is 6 meter into OL. The distance of OL, we don't know the distance, so took as OL. 6 into OL by 2. Now, OL, when you consider this triangle ORL, we can identify that this is a right angle triangle. So by Pythagoras theorem, we can say OL square is equal to root of OR square minus RS square. 6 into 6 is the distance of RS. So we took 6 as itself into OL means root of OR square plus RL square by 2. By 2 is the previous one. By using the we need to write the reason also by Pythagoras theorem. Now, OR, what is OR? OR is given as 5 meter. Let's we took 5. RL means RS by 2 because it is the line. OL is the perpendicular line from the center to the chord RS. So it bisects the chord as equal part. So we can write RL means RS by 2. So RS we know 6. So 6 by 2 is equal to 3. 6 into root of 5 square minus 6 by 2 whole square by 2. That is 6 into root of 25 minus 9 by 2. That is 25 minus 9 is root of 16. That is 16. Root of 16 is 4. 6 into 4 by 2 is 12 meter. That is equation number 2. In the previous we took one equation as 5x by 2 and now we get 2. From equation 1 and 2 we can write both are areas of triangle ORS. Both are area of triangle ORS. So from both two equations we can equate these two. 5x by 2 is equal to 12. From this we can find out the value of x as x equal to 12 into 2 by 5 which is equal to 24 by 5 is equal to 4.8 meter. Now we get the x 4.8 meter. We took kr as x. We took kr as x meter. Kr as x. We need to find out rm itself. If kr equal to 4.8, rm is equal to 2 kr 9.6. So the distance between Reshma and Mandeep is 9.6. Distance between Reshma and Mandeep is 9.6. I think it is clear for you.